So here we've been given an equation which shows arsenic reacting with sodium hydroxide, and that produces sodium orthoarsenate and also molecular hydrogen. We've been told the mass of arsenic that reacts with the sodium hydroxide, and we've been asked to calculate the mass of the sodium orthoarsenate that is produced from the reaction. Okay, well, we're gonna need, if we're trying to work out the mass of the sodium orthoarsenate, we're gonna need to work out the amount of substance, right? Which is not necessarily straightforward to do directly. So in order to get to a point where we have that, what we're going to need to do is some stoichiometry. And well, the starting point based on the data we have in the question would be with the mass we've got of arsenic. We can work on converting that to an amount of substance, and then use the ratios in the question to work out, well, what's the amount of the sodium orthoarsenate. Now, we've been told in the question that NaOH is in excess, and that's important because given that it is in excess, it means that the limiting reagent is going to be the arsenites, right? So, and that more or less tells you that the sodium orthoarsenate here produced is going to be contingent on the mass of arsenic, right? So I'm going to go ahead and go through the process of working out, well, how much amount of substance of arsenic is present, right? And if we refer to the equation, so mass is equal to moles multiplied by molar mass, MR, right? Using the equation, if we rearrange that, what we know is that the moles N, right, so this is rearranging by dividing both sides by the molar mass. What we know is that the moles N is effectively going to be equal to the mass divided by the molar mass, right? So when we apply this to arsenic, we've got the 49, so that would be equal to 49.65 divided by, and so the molar mass of arsenic, we can find that out from the periodic table. So we're going to look over there. So you can see arsenic is here. So we've got the relative atomic mass is 74.9, right? So which is basically, so the MR, we can say that the MR of arsenic, which is just elemental arsenic, is 74.9 grams per mole, right? So this is the molar mass. So if we insert that into the equation we just started, 74.9, and that's going to give us our moles. So if you work that out, you should be able to find out what the moles of arsenic is on the reactant side. And so that gives 0.66 28838 moles. Okay, and from this point, what we need to do is we need to take a look at the stoichiometry in the question effectively. We need to look at the molar ratios. How does the moles of arsenic compare to the moles of the mass of the, that we're trying to solve for, how does it relate to the amount of substance specifically? Well, if we set up a little comparison here, so I'm going to say the moles of arsenic compared to the moles of Na₃AsO₃, right? If you look in the question, what you can see is that clearly there's 2. There's a coefficient of 2 next to the arsenic. There's a coefficient of 2 next to the sodium over arsenate. So it's the same, more or less, right? So it's 2 to 2, right? And if we divide this by the factor, the common factor of 2, you simply get a 1-to-1 ratio, right? Therefore, what we can say based on this is that the moles of the sodium over arsenate is the same as the moles of the arsenic, right? So that therefore is going to be equal. Therefore, the moles of Na₃AsO₃ is going to be equal to 0.66. So it's just going to be the same, right? So 28838 moles. And because we've now got we've got the moles anyway. What we need now, if we look back at the same equation, which if I write it out again, just we get mass equals moles times molar mass, right? So we have the moles. We can work out the molar mass from the periodic table. So that's for Na₃AsO₃, right? And so let's take a look at what the molar mass would be for this. So if we refer to the relative atomic masses, you've got sodium here, 23, right? You've got arsenic, 79, and oxygen as well, right? So that's going to be 16. So you can set up effectively some arithmetic that will give us the molar mass of the sodium over arsenate. So that's going to be and I'll put MR here. MR of this is going to be equal to 23, so that's for the sodium, multiplied by 3, right? So it's Na₃ plus then 74.9 plus, and that's going to be added to what relates to oxygen, which is going to be and this is just, I'm just writing this as 74.9 because otherwise I would have been writing 74.9 times 1, which is, I mean, it's the same thing, right? So okay, and then for oxygen it's going to be 16 multiplied by 3, okay? And so if you have a go, I would invite you to have a go and work out what that is. Okay, so if you did have a go at that, you should have found that you got 191.9, right, grams per mole. So we can now use this value we've worked out, 191.9, and effectively use it in this equation. So therefore we're going to say we'll say therefore the mass, right? So mass of Na₃AsO₃ is equal to 1. So the mass, I mean the molar mass, right? So the 191.9, right? So that's the MR, just for clarity, multiplied by the number of moles, right? So 0.6628838, right? And so that's the number of moles. And so I'd invite you to have a go work out what value for the mass you get when you do that calculation. But we should find is that you get 127.207, and that's going to be in grams, right? And that's gonna when we look at the actual question, what you find is it does say give your answer to a maximum of 2 decimal places, right? So if we do look carefully at our answer so far, it doesn't quite adhere to that requirement. So we are going to need to do some rounding before we've got the actual quote-unquote answer as specified or as requested. So we need to take that important step of, okay, in this case, we're going to need to round that 0 up to 1, right? So right. So in this case, this would be the answer, right? 127.21 grams. Now, with regards to the reaction we saw above here, although maybe it looks like an interesting piece of chemistry, under no circumstances try that at home. Sodium orthoarsenate is a very, 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 very toxic. It's very toxic chemical. It's carcinogenic and a whole bunch of other nasty things. So, but anyway, nonetheless, as far as calculating masses, I hope this was useful.